As the basic operation of maths goes, let us add joy, subtract fears, multiply sanctity, and divide the grace of God among ourselves this morning by singing the school prayer song.
A warm word of welcome to all. We, the Studyites, take privilege in celebrating our school's last day of Virtual Maths Week, KYMIP 2020, which is Know Your Math in Pandemic. It gives me great pleasure to welcome our chief guest, Dr. T. Juraviz, former HOD of Math Department, Pondicherry University. His area of specialization is commutative algebra. He holds a PhD in algebra, generalized math-less reflexive modules, spectral topology of modules, extension of theorem of Eisenberg and Gorenstein rings. Sirs, we hope our culturals and exhibits that we present to you today are eye-catchy and worth your time. Let us begin our program with an inspirational thought. The essence of mathematics is not to make simple things complicated, but to make complicated things simple. I am sure that the percentage of excitement will increase as you witness the following programs. We assure you that our programs will entertain you. As the angles dance in geometry, here comes Refi with a classical performance.
Every portion in them is a geometric definition of space, and every moment is a calculated definition of time. Together, dance is an associative definition. I am demonstrating a small choreography which explains the relation between space, time, through and every art has its science. Dance is created by defining space and time. Every posture in dance is a geometric definition of space, and every movement is a calculated definition of time. Together, dance is an associative definition of mathematics. Here, I am demonstrating a small choreography which explains the relation between space, time, through attributes and postures.
takita ta ta jum kirdiga jum ta num ta rum ta takita ta tangirdiga tarigirdiga ta tarita ta danata ta runata ta dinita ta jum ta num ta rum tagadim takirdiga angirdiga tarigirdiga ta dim ta tarigirdiga ta jum dim ta jum nam ta jum tam takita danata tangirdiga tarigirdiga dim ta tarigirdiga ta jum dim takita jum takita tak jum ta jum takita ta jum kirdiga tarigirdiga ta jum tarita ta tarita ta tarita ta tarigirdiga tarita ta tarita ta jum tarita danata tangirdiga tarigirdiga ta tarigirdiga ta jum dim ta jum nam takita jum ta dim tom nam tangirdiga tarigirdiga ta tarita ta tarita tarigirdiga tarita ta tarita dim tarita ta tarita 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 tangirdiga tarigirdiga ta dim tarigirdiga ta dim tarigirdiga ta jum tarigirdiga tangirdiga tarigirdiga ta.
Thank you for that soul-stirring dance performance. Next, we have the students of class 12 to integrate us with numerous facts and quotes about maths.
Hello all, hope you guys are doing good.
This is a short preview to our maths even in quarantine.
Okay, let's get started.
I read millions of words from English, but no word perfect enough to describe the mathematics.
Not gonna bore you guys with facts of maths, I promise.
I heard enough of people saying maths is tough, but not to the one who is bored of facts.
Once a mathematician said, if people do not believe that mathematics is simple, it is only because they do not realize how complicated life is.
Good morning, sir. Hello, Samir. Sir, I have a doubt in math. Yes? What's your doubt? What are the operations involved in math? Basically, 4 important operations are there, namely addition, subtraction, multiplication, and division. What is the ratio between addition and multiplication, sir? Multiplication is the process of using repeated addition. Thank you very much, sir.
Mathematics stands for
M for miracle of nature.
A for art of arithmetic.
T for tool of knowledge.
H, habit of problem solving.
E for evaluation of civilization.
N, magic of numbers.
A for application of rules.
T stands for talent to prove.
I stands for idea of intellect.
C for creativity of algebra.
S stands for science of learning.
All these phases said by my friends are just a partial definition for math. A perfect word for math is yet to be found.
Kind of boring, isn't it? Come on, let's make it interesting.
In English, you can't spell an odd number without the letter E.
From 1 to 1000, there is only one number with letter A, which is 1000.
4 is the only number which when spelled has the same number of letters as the number represents.
Recent researchers proved that 0 is an even number.
Even though the cube roots were found in 1st century CE, the correct way to find cube roots of any integers was found by an Indian mathematician, Brahmagupta.
Okay, I guess that's enough of facts today.
Just talk me about a wonderful maths.
Maths, அது ரொம்ப கஷ்டமாச்சுப்பா. அது வரும் பாரு, a square plus b square plus 3ab. அதெல்லாம் பார்த்தா
அது 3ab இல்லடா 2ab.
ஏதோ ஒண்ணு, எல்லாம் மேக்ஸ் தானே.
See you, math is not about memorizing formula. It's about understanding. When you see a problem, and if you know the concept behind it, the problem tells you the next step to do, and that step tells you the next step, and it goes on.
In all other subjects, you need to know the final answer of the question. In maths, you just need to know the next step.
இதுக்கப்புறம் எப்போ அண்டர்ஸ்டாண்ட் பண்ணி சேஞ்ச் பண்ணி
It's not so tough. It's all about taking the first step.
KK boys, enough. Let's get to the point.
Equal to 7. 28 by 4 is equal to 7. 28 by 4 is equal to 7. 28 by 4 equals to 7. 28 by 4 is equal to 7. 4, 2, 3, 6, 2, 4, 8, 2, 5, 10, 2, 6, 12, 2, 7, 14, 2, 8, 16, 2, 9, 18, 2, 10, 20, 2, 11, 22, 2, 12, 24.
In the joy of celebrating magic, we forgot the vote of thanks.
It is a great honor for we students to host the first ever virtual Maths Week.
Even though we had a lot of struggles to continue our studies, you teachers didn't stop supporting us from learning.
We thank all staff of the Math Department for giving us the opportunity to conduct this wonderful virtual Math Week.
Last, we would like to conclude with a quote. Mathematics is not about numbers,
Equation,
Competition.
And algorithms. It's all about understanding.
Thank you for juggling our minds with your facts. I'm pretty sure that in a fraction of a second, you will be overwhelmed with the display on your screen.
Good morning, everyone. This is Son of Class 10A, and today I'll be presenting my topic, Understanding Life Through Mathematics. In this presentation, I'll be covering these topics and I'll explain how we can get inspiration from them. During this pandemic, we have been presented with one of a kind of challenging situation, but we must perceive this in an optimistic way. Now we have an opportunity to explore things, innovate, and many more. In a similar situation like this, Sir Isaac Newton developed many ideas such as calculus, theory of optics, and also discovered the concept of gravity. The following slides show us how to lead life with inspiration from maths. It is a general saying that human beings are not perfect in everything. Such type of an idea is presented by the Harry-Ball theorem. The Harry-Ball theorem of algebraic topology states that any continuous tangent vector field on a sphere must have a point where the vector is 0. This theorem has found its applications in computer graphics, geometric optics, weather systems, and ocean flow. This theorem guarantees us that there is always at least one point on Earth where there is no wind and ocean flow respectively, as the Earth is a vector field. In the case of cyclones, this can be considered to be the eye of the cyclone where the weather is relatively calm. As it is impossible to comb all the hairs on the ball, similarly, perfection is an unachievable goal. Therefore, it is important to give our best and celebrate our progress. William Shakespeare had famously said, "The choices we make dictate the lives we live." A similar type of idea is presented by the chaos theory. Chaos theory is an interdisciplinary theory stating that within the apparent randomness of chaotic complex systems, the underlying patterns, interconnectedness, constant feedback loops, repetition, self-similarity, fractals, and self-organization. The butterfly effect is an underlying principle of this theory. It is the sensitive dependence on initial conditions in which a small change in one state of a deterministic nonlinear system can result in large differences in a later state. It can be colloquially said that if a butterfly flaps its wings in China, it can lead to a hurricane in Texas. There are many real-life examples of this theory. In the period of 1900s, when soldier Henry Tandy was fighting in France, he decided to spare the life of one German child. This child later turned out to be Adolf Hitler. If the soldier had decided not to save the child's life, many major events such as Holocaust and World War II could have been avoided. This effect can be understood with the help of a double pendulum. As you see, the difference of the angle by 0.1 degrees has led to a drastic change in the way the lines are being drawn in the second pendulum. This theory has its applications in biology, geology, physics, astronomy, and many more. In fluid dynamics, this theory has its applications in the turbulent flow of water. As you see, the flow of water is random and in a chaotic way. And in the right video, we see the particles moving in Brownian motion. Here too, the particles are moving in a random way and the motion is chaotic. Actions taken towards one goal can have a tremendous difference in the final outcome. Similarly, during this situation, the choices we make as citizens can have a major impact on the way the disease is spread. If we make the right choices, we can curb the disease and the curve will be like the one shown in yellow. If we do not make the right choices, we will not be able to curb the disease and the curve will be like the one shown in blue. Many factors may have affected our progress towards our goals. Our output may have been reduced, causing uncertainty towards future. This can be understood with the help of a harmonic series. Harmonic series is a divergent infinite series. It is a series formed by taking reciprocals of arithmetic series. This series has found its applications in geometry, architecture, and many more. In a triangle, if the altitudes are in an arithmetic series, then the sides will be in a harmonic series. In architecture, this series can be seen in the leaning tower of layer. It is a tower formed by placing uniform blocks upon one another, but the lateral distance is reduced in the order of 1 by 2, 1 by 4, 1 by 6, and so on. This ensures that the center of mass is just at the center and it prevents the structure from collapsing. Even though the successive numbers of a harmonic series are smaller than the precessive ones, they add up to infinity. Like the harmonic series, the size of our steps do not matter. The sky may be still the limit. Mathematics is not only important for success, it is all around us. It makes our life orderly and prevents chaos. It nurtures qualities such as creativity, critical thinking, problem solving, and many more. The problem solving skills obtained can help us to tackle problems in our life. While many may complain that maths is difficult and complicated, a life devoid of math would not be as interesting as it is now. It also offers a field to innovate and makes our life easier. It can be said that the development of math has led to the evolution of man. The life lessons it teaches through various means will certainly help us to understand life and make it easier. I would like to conclude my presentation with a quote of Archimedes. Thank you.
Good morning to all. I am Archisha of class 12 and today I am here to present a presentation on India's great mathematician, Mr. Srinivas Ramanujan. He is also known as the man who knew infinity. He was born on 22nd December 1887 in Kombokoppam, but due to his illness he died at the age of 32. His first work was published in Journal of Indian Mathematical Society on the properties of Bernoulli's theorem. Ramanujan's nested radical for a given integer n expressed by him as a simple sum of three parts. He worked on Riemann series, elliptical integrals, hypergeometric series, and the functions equation of zeta function, along with his own theory of divergent series. But he faced problems in periodic function, quadratic theory, and some mathematical proofs. Ramanujan found the partition formula where he can calculate in many ways. The number can be created by adding the numbers together. For example, 4 can be written as 1 plus 3, 2 plus 2, 1 plus 1 plus 2, 1 plus 1 plus 1. Ramanujan discovered the number 1729 as the smallest natural number which can be written as the sum of cubes in two ways, that is 1 cube plus 12 cube, 9 cube plus 10 cube. And also, incidentally, it's the product of the prime numbers, 7 into 13 into 19. Ramanujan's health deteriorated in England and was diagnosed with tuberculosis and vitamin deficiency. Eventually, he died at the age of 32 while returning to India. Ramanujan left behind 3 notebooks and the sheets of pages known as Lost Notebook, which has many unpublished results. He became the Fellow of Royal Society in 1918, and the stamps were released by Government of India in his remembrance, and the date, 22nd December, being his birthday, has been declared as National Mathematical Day to be celebrated every year in India.
Thank you.
Hello everyone, I'm Shivaji from grade 7 and today I'm going to be explaining about some properties of the triangle. So before explaining about the properties of triangle, I would like to explain to you what is a cyclic quadrilateral. A cyclic quadrilateral is when all four vertices of a quadrilateral touch the circumference of a circle. See, like this one here, all four vertices are touching the circumference. It doesn't mean that only these 4 points. It can be even like this or even like this also. See, because here all four vertices are touching the circumference. But if you see here, okay, these 3 may be touching the circumference, but this one it's not touching. So this is not a cyclic quadrilateral. So here in the first property, it is that the central angle formed here by this point is the double of the angle formed here. So in this property, these two triangles have a common base and 2 of the vertices are common both on the circumference. So here the third vertex on the first triangle is in the center and the third vertex for the second triangle can be anywhere on the circumference. I have placed it here so we can check it. Suppose, so here this is actually 130 degrees and this is 65 degrees. So by this itself we can know that the angle formed here is the double of this angle. So here for the second property, when the base of a triangle is the diameter of the circle, the third vertex is anywhere on the circumference. No matter where you keep it, it will be 90 degree. Now here, or even if you keep it here, it's going to be 90 degree. So here we can measure it. It's 90 degree. So here for the next property, both of these triangles are having the same base, and because of this, the angles formed here near the third vertex are the same. No matter where they are, but as long as they are on the circumference, no matter even this one, even if it is here also, both these angles are the same. We can measure it if you want. So first, this, it is 60 degrees and this also, it is 60 degrees. So both the angles are the same since they have a common base. So here for this property, we have a triangle where its base is the diameter and all 3 vertices are on the circumference. So for this property, if we flip the triangle the opposite side like this, we get a rectangle. So for the last property, we have a cyclic quadrilateral. And in this property, the sum of the angles of the opposite vertices will be 180 degree. Not only for this cyclic quadrilateral, but for any cyclic quadrilateral, the sum of the angles of the opposite vertices will be 180 degrees. We can measure for this one. So here we have this 100 degrees and here this is 80 degrees. So 100 plus 80, 180 degrees.
Interesting mathematical facts. 0 is the only number which cannot be represented by Roman numerals. Plus minus sign symbol were used as early as 1498 AD. 2 and 5 are the only primes that end in 2 or 5. Among all the shapes with the same perimeter, a circle has the largest area. The number on the opposite faces of the die always add up to 7. From 0 to 1000, a letter A only appears in 1000. 0.9999 is exactly equal to 1. If you fold a paper 103 times, it would be the thickness of a universe. The largest prime number ever found is more than 22 million. In a room of 23 people, there's a 50% chance that 2 people have same birthdays. 4 is considered unlucky in Asia. 40 is the only word that is spelled with letters arranged in alphabetical order. Every odd number has E in it. Most popular favorite number is 7. Abacus is considered the origin of calculation. Thanks for watching.
I am sure that you everyone enjoyed it. Now let's hop on to the strum of Shivaji's guitar. Thank you, Shivaji, for that instrumental delight. A painter paints pictures on canvas, but musicians paint their pictures in silence. Here comes Mughal with a song.
Differentiation and integration இது மகடிச்சுதா ஒரு confusion. Limit x into 0 sin x by x equals 1. Limit x into 0 1 minus cos a by x is 0. Newton பிறந்து வளர்ந்து படித்து calculus எழுதினா நம்மளுக்கு ஆரியபட்டா trigo கொடுத்தார் நம்ம 12th math portionக்கு uv whole derivative is u dash v plus v dash u. ஆனால் u by v whole dash to minus and down v square. Differentiation of x over n கிட்ட மண்டைய சொரிய கூடாதுமா. x to n power n minus 1 சொல்லி எழுதி தள்ளிட்டு வந்திடுமா. ஆனால் நண்பா இவை எளிது என்பதால் சீமென்ஸ் இங்க சைனுங்கம்மா. cos x cosec x வந்தாலே minus n ஃப்ரண்ட்ல வருமாமா. Differentiate tan x is secant square x. Differentiate sec x is secant x tan x. Cos x to c so minus cosecant square x. Cosec x to c so minus cosecant square x. Mathematics rumbo. Mathematics rumbo. Mathematics rumbo. Mathematics rumbo easy da. power n plus c mara khagera x power n plus 1 by n plus 1 to mangalinda my mari do mara integral cos x equals to sin x integral sin x equals minus cos x 6 square x 1 dilum tan x tandilum cos 6 square x minus cot x 6 tan x sec x cos 6 cot x minus sec x integral e power x e power x medu யோசிச்சு எழுது integral a power x by log a 1 by x to x square minus 1 sec minus x or minus x again minus x integral 1 by 1 minus x square equals sin minus x odd minus cos minus x இருவரை ஒன்றாய் கலந்தது அடியே 1 by 1 plus square க்கு tan inverse x or minus cot inverse x இவை மட்டும் தெரிந்த சந்தோஷமே மனமே x value தேடி நான் தொலைஞ்சேன் மனமே அட ஒன்றும் தெரியாம தெரிஞ்ச மனமே அட ஃபார்முலாவை நான் படிச்சேன் மனமே பின்பு எழுதி தள்ளிட்டு மூஞ்சில் அடிச்சேன் மேத்தமேட்டிக்ஸ் ரொம்ப ஈஸி தான் மேத்தமேட்டிக்ஸ் ரொம்ப ஈஸி தான் Mathematics ரொம்ப easy தான் Mathematics ரொம்ப easy தான் Mathematics ரொம்ப Mathematics ரொம்ப Mathematics ரொம்ப easy தான் மனமே x value தேடி நான் தொலைஞ்சேன் மனமே அட ஒன்றும் தெரியாம தெரிஞ்ச மனமே அட ஃபார்முலாவை நான் படிச்சேன் மனமே பின்பு எழுதி தள்ளிட்டு மூஞ்சில் அடிச்சேன்
Thank you, Mughal, for those pitches and tunes. Our little chaps of class 4 don't need wings to fly. Their cuteness is enough to make them soar above the sky. Here they come with their little dance.
Here we go in 1, 2, 3, 4. So it's finally time to learn about division. It'll be a breeze if you know multiplication. I've got your back for sure. 12 divided by 4. 12's a total and 4 can be the groups of time. Yo, what does time mean? It stands for things in each. The choice is yours, but make sure you can model both ways. Everybody jump on in, yeah. We're on a mission. Mastering that division. You may be saying it's like multiplication. Just in reverse, that's cause they're inverse operations, but in division, we know that the total's given, equally splitting or separating to determine the unknown. Here's a word problem for you, pause it if you need to. No, really, you should probably pause it. We know the total and the number of groups. We must find the things in each. In this case, how many B's? 16 divided by 2. Let's draw it out. Dividing equally. How many B's do you see? In each side there are 8. That's how close it is. Everybody jump on in, yeah. We're on a mission. Mastering that division. You may be saying it's multiplication. Just in reverse, that's cause they're inverse operations, but in division, we know that the total's given, equally splitting or separating to determine the unknown.
I'm sure that their tapping feet led rainbows to your eyes. Now allow me to take you to a whole new world of maths.
Good morning to everybody. I am Gopika Raj and today I'm going to talk about a mathematician slash philosopher called Plato. So who was Plato? Plato was a Greek philosopher born in Athens, in the city of Athens, in 428 BCE. So he was technically a philosopher, but he has also contributed to the mathematical world. And in his views of mathematics, he was convinced that geometry was the key to unlocking the secrets of the universe. So he thought of geometry as something that high. He was very influenced by another mathematician who you must have heard of, called Pythagoras. And according to Pythagoras, mathematics was a branch of philosophy, and Plato also thereby taught mathematics as a branch of philosophy in his academy. His teacher was Socrates, and his most famous student was Aristotle. Now, this is what Plato's academy looked like, and it was a beautiful place. It was called the Academy of Athens. This academy was founded in 387 BCE, and it was the first European university to last over 900 years. And over the main entrance of this university, he had written this phrase, "Let no one unversed in geometry enter." So it was a school based on geometry. And throughout his life in this school, he taught philosophy, obviously, mathematics, and sciences. And he also made a lot of prominent mathematicians, and therefore he was called the maker of mathematicians. Some of his most famous disciples were Eudox, Theaetetus, and Aristotle. Now here's a picture of Eudoxus and Aristotle. Now, this is one of his contributions to mathematics, where he made new mathematicians who were very prominent and very important figures in our history. And he also did this. He also introduced to us a few solids, which we call the Platonic solids. Now, what are these solids? Platonic solids are basically just convex polyhedrons. Why are they convex? It's called a convex polyhedron because all of its faces curves towards the center of the figure. Therefore, it is called a convex polyhedron. And you create this, or you construct this, by combining together or putting together multiple congruent shapes. So if you take a triangle, you put together actually in this case, 3 triangles. And when you put together 3 triangles in such a way that their edges touch together, then they form a shape. And that shape is called a platonic solids. The condition is that all of these spaces should be congruent, and the number of faces at every vertex should be equal. So now, because of these strict conditions, there are only 5 platonic solids, of which we will see later in this presentation. And Plato associated these solids to the 4 basic elements in the universe at that time, which was fire, air, water, and earth. And people believed that every other element in the universe, or every other material in the universe, was made up of these 4 basic elements. And so Plato thought of these 5 solids as these 5. He associated these solids to these 5 elements. And he developed a theory of the universe based on it. And therefore, these solids came to be known as the Platonic solids, using his very own name. Now, what are these Platonic solids? The first one is a tetrahedron, where you can see there are 4 triangles put together, and at each vertex, there's 5 faces that join together. And this solid was assigned to the element fire. Plato assigned the solid to the element fire. The next solid we have is a cube, which is a very common solid. I'm pretty sure everybody knows about it. It is a six-faced shape with all squares on each side. Every face is square and there are 6 squares. And this was associated to the Earth. And then we have the octahedron, which, like its name says, 8 triangles. So 8 triangles put together, and at each vertex there are 4 triangles. And this represented air. Then we have the icosahedron, which was symbolized or which was associated to water. Here we put together 20 triangles, where you can see at each vertex there's 5 triangles. It was given water. And then the third figure, or the third 3D shape, was the dodecahedron, which was basically the 5th element. It was made up of 12 pentagons, or put together. And since it was 12 pentagons, Plato associated it with the 12 constellations in heaven, and therefore he assigned this shape to the heavens. So this is how Plato influenced the mathematics field. He introduced a lot of new scientists, and he introduced this concept of Platonic solids. So he did play a pretty prominent part. Thank you. I hope you enjoyed this presentation.
Hello friends, this is Kritika and I'm going to speak about Sudoku and the tricks that you can use today here. And at Sudoku, it is usually for the brain-filled people. Sudoku is one of the games that is going to be played using grids. Actually, there are 9 grids. Each have 9 cells. You can use numbers 1 to 9. And in such a way that every column and every row has the numbers 1 to 9 without repetition. This is one of the high IQ game. It develops your intelligence quotient. And I'm going to tell you 9 tricks and tips that you can use today in this game. The first trick that we're going to see is naked singles. As you can see from the grid over there, in the 8th column, there's only one that is being remarked with green. It is called a naked single because in that particular cell, you can't apply any other candidate except for one. Only one can be applied to that candidate. So that trick is called naked single. The second trick is hidden singles. Usually that kind of singles aren't actually always visible, so you have to find out them. So as you can see in the grid again, you have 6 that is being highlighted, but you feel like there are also 4 and 9. But when you cancel out, you're going to have only 6 that can be filled there. So this trick is called hidden single. The third trick is naked pairs. As we saw, there are on the 8th row, you can see 3 and 9. The pair of numbers, that is 3 and 9, only that can be filled. That means one box should contain 3 and the other should contain 9. That is called naked pairs. The fourth one is called pointing pairs. You can notice on that remarked ones, on the first 2 cells, you actually contain all the numbers that is going to be there, like 1, 2, 3, 4, 5 till 9. You're going to have them. This is one of the special case that we can see, like every time this can't occur, but this is one of the special case that's called pointing pairs. Number 5 is claiming pair. That means you can see in the second row you have 7 repeated. So when you're going to have in a row, then you can fill it only there. I mean, in the red 7 cannot be filled over there. It can be filled only over the second row. That is called claiming pair. The sixth trick that we're going to see is naked triples. You can see naked triples over there, like that you have to see is 1, 2 and 6. Usually they occur in every term, but you can eliminate, like when you fill 1 there, you can eliminate it from mostly everything, right? You can eliminate from everything so that it becomes easy for you. This is one of the tip that you have to use in Sudoku. Like when you're going to fill, first you have to try to fill 1 so that you can remove 1 from every other place. The seventh one is X-wings. You can see X-wings in the second row as well as actually it's the 6th row, I think. No, it's 5th row. You can see it from the 5th row. That 4 numbers, the remarked 5, they form like a square. When you join them, you have something like X. When it comes like that, you're going to fill it only at 2 places and not in the same row or same column. You're going to place it in the as if they are vertices of the X. So you're going to fill it over there, or not on the same row or the same column. The 8th tip is hidden pairs. Pairs are always not visible. Sometimes you have to find them by cancelling out and eliminating the other terms. These are called hidden pairs. 9th one and the last one is naked quads. Naked quads are 4 numbers. Actually, sometimes the 2 numbers get repeated again, but naked quads, it can even have 4 numbers. It occurs when 4 cells in a group contain no other candidate other than the 4 candidates. Like when you see that the remarked green ones, 3, 3, 9, 9. In that 2 cells, we don't have any other number, so we have to fill 3 in one and 9 in other. So it makes things becoming easier over there. And this is the end. Thank you.
Good evening, my dear friends and respected teachers. My name is Ritinkar from section 8B, and I'm studying on the study net called Antanyasana from Pondicherry. Today I'm going to do something very interesting. I'm going to tell you how to find the day of any date given. But before we begin, I'm going to show you something which will make very easier for you guys. It is, I've made for you a month code, century code and a day code. So these codes, you cannot show them to others when you're performing it. It should be a secret when you're performing with your friends or your parents. So let's not waste any more time. Let's get into it. Now let's take any random date. So let's say we take my birthday, which is 8/10/2006. So here in this box, you're gonna write an 8 as it is. I'm gonna write 8. Now 10 is what? 10 is a month. So what is the month as shown in the month code? 10 is October. What is the code of October? 1. So I'm gonna write a 1 here. Now 20 is actually a century code. What is 20 here? 6. So I'm gonna write a 6 here. Now the 06, you can write as 06. If you want, I can write 6. I'm gonna write a 6 here. Now the last box is for a leap year. So that means how many leap years are there? 6? 1, right? So I'm gonna write 1. Now we should add them up. So 8 plus 1 can be 9, 9 plus 6 15, 15 plus 6 is 21, and 21 plus 1 can be 22. So now this 22 is not the final answer. So you know, we there are 7 days. So what should we do? We should do 22 divided by 7. So what do you get here? You're going to write 3 here, 21, and you get the remainder as 1. So now you're going to take the remainder as 1 as it is. So you're going to take 1. So what is 1 here? So 1 is a Sunday as shown in the day code. That means 8/10/2006 fell on a Sunday. And now let's take another day. So let's say we take yesterday's date. So let's say yesterday is going to be 29, and then 09 and 2020. So as you all know, 29 is written as it is, a 29 is here. 9 is September. So the September code 6. I'm gonna write a 6 here. 20, as well as 6 here, so I'm gonna write a 6 now. This 20 is gonna write as it is. 20, and now how many leap years are there in 20? 5, right? So I'm gonna write a 5. Now again add them up. 29 plus 6 gives you 35. 35 plus 6 will give you 41. 41 plus 20 will be 61. And 61 plus 5 will give you 66. Now 66 divided by 7, if you do, going to give a 9 here, 63, and 3 is remainder. So as you should take always a remainder is going to be 3, and 3 is a Tuesday. And of course you all know today is a Wednesday, so that means that obviously yesterday had to be a Tuesday. So my dear friends and respected teachers, I hope you enjoyed this game, and I hope you can perform it in front of your friends or parents. Thank you very much.
Thank you for the amazing exhibit. Now I invite our beloved chief guest to inspire us with few words.
Hello, I have to speak now. Hello, can you hear my voice?
Yes, sir.
Yeah, shall I start? What? Okay. So all of you, good morning. So I am very happy to be with you today. So I first thank Principal Madam and teachers organizing, the teachers who are organizing the functions, and the students who is actively participating in it, to give me the opportunity to mingle with you today. This is always interesting to meet young children who are filled with enthusiasm and eagerness, okay, to learn more things. This makes me feel very young, and also motivate me to do more active. Okay, you are celebrating this week as a mathematics week. So mathematics is very fundamental for all branches in sciences. You know that mathematics is used in day-to-day life, even from small money transactions, and also to big level finances in stock market and other things. Actually, they are using very sophisticated mathematical equation to guess what could be the next price, like that. So they are earning money out of using this mathematics, the equations. Okay. So you may be surprised, even in the medical field, you may think, what is the use of mathematics? Actually, the growth of cancer cells, tuberculosis, and so many diseases, how it spreads, even in this COVID case, the mathematics are used as statistics under many ways. Okay. Actually, mathematics is what? It is like a toolbox. You know that. Suppose you may have a 50 lakh car, you are driving, and on the middle of the way, the tire is punctured, you want to change the tire. You have the Stepney tire, everything is there, but suppose that spanner is not there, you are not able to change it. A small spanner will collapse your travel, isn't it? So the tools are very important. Similarly, whatever physics problem, chemistry problem, or whatever problem, mathematics supplies tools to solve that problem. So you may consider mathematics as a toolbox. Okay. So, and another thing, so mathematics teaches how to think properly. So now people are thinking, they are having fighting, there are some communication gaps, so many problems are there. But the mathematics tells that how to assume things, how to go step by step, logically, and derive a solution. So in that way, if you think mathematical way, you may not get any wrong decisions. You may not take any wrong decision. Okay. So if you do mathematics, you understand and do the mathematics, you will that will teach you how to think properly. So actually mathematics is what? It's a pure truth. There is no change. The mathematics truths are unchangeable. Okay, in any part of world. Here 3 plus 2 5 means wherever you go 3 plus 2 is 5. If you go moon, it is 3 plus 2 is equal to 5, isn't it? But not other facts. Suppose here you can jump for 3 feet in earth. If you go to moon, you can jump for 9 feet. Okay, so the other results, other science results may change time to the place to play. But mathematics is true. It is unchangeable everywhere in the universe. Okay. You know that. Suppose that moon is rotating around our earth. Earth is rotating our sun. Okay. See, the time is exactly the same thing. In this time, Earth will be in this position, we can calculate. Everything is doing properly. Why? They are following some mathematical equation. So physics people may know that G into M1 into M2 by R square is the equation for this rotation. Newton found it. So every things in the world, for example, H2O, 2 hydrogen, 1 oxygen, that ratio, all other things are mathematical equation. Finally, an atom, so number of, so atom differs by varying the numbers, a number of protons, electrons, and neutrons, isn't it? Finally, everything comes into mathematics. That means what I want to tell you is the whole universe is written in the language of mathematics. Okay, they follow the rules books. The rule book of universe is mathematics. That is why we have exactly 24 hours per day. Seasons are coming in correct time, and we can send satellites to moon in correct exact position, and so many things we are able to do because universe strictly follows mathematics. Okay, so so in a way you can consider mathematics is a knowledge, is a language. This is the language we are writing. Whatever we find in the real world, we are writing in a mathematical formula way, in simple form. For example, you want to describe a circle. In whatever way in English you circle, if you describe circle, you may have flaw. But in mathematics, we will tell x square plus y square is equal to, for example, 100. This is the equation of a circle of radius 10 with the center at the origin, like that, no? So this is the perfect way of defining a circle, telling a circle, isn't it? So mathematics is the perfect language. You may consider mathematics also as a language. Like that, we can tell a lot of many great things about mathematics. So that is why mathematics is considered as a queen of sciences. You know that mathematics is considered as a queen of sciences. You know the power of queen in chessboard. Okay, yeah. So mathematics is such a powerful thing among the sciences. So mathematics is a fascinating subject. It is interesting. Not only just a subject, it is this one. This is like, it attracted many people to devote their whole life for mathematics. For example, for Srinivasa Ramanujan, mathematics, what gave him back? No, he is poor and he is running here and there for single time food. So but at the same time, he is very much interested in mathematics. At the beginning, mathematics is not helping him to give money or something, but he is attracted. Like, okay, so he devote all his life. Okay, so why mathematics is interesting? It is like a art. I told you, mathematics is a toolbox. It is a language. It is a pure truth, like a philosophy, like that, and it is also like a art, like writing a poem. Like the poets are devoted to their life to write poem. No, so people are devoting their life drawing pictures and music, like that. Like that, people are devoting their life to mathematics just for enjoying mathematics. Okay, so it is a more interesting subject in their this one. So you ask somebody who is very good in mathematics, ask him, what about mathematics? They will tell that mathematics is the easiest subject in their education system, and more interesting thing in the education system. So some people are telling that. At the same time, quite a bit of people in the world consider mathematics as a difficult subject, and without any hesitation they tell, I am afraid of mathematics. So you can see many big people, actors, or somebody, they will proudly tell, I am afraid of mathematics. I don't know why. Why they are afraid of mathematics? Why there is a fear in mathematics? I don't believe that some people are born with mathematical knowledge and others without it. No, all the people are born with equal knowledge. So how some people develop interest in mathematics, some people have fear in mathematics, because how mathematics is introduced when they are in the children, that plays an important role in their life. Okay, so those students who were taught to enjoy mathematics consider mathematics as an easy and interesting subject. This is the thing I want to tell you. So how to learn mathematics? You learn mathematics by enjoying it. You do a problem. Every problem should become a puzzle. So some student now describing how to solve Sudoku. Why people are interested in Sudoku? What it is going to give you? It is going to give you the intellectual pleasure. See, we are enjoying pleasure in many ways. When you are sitting in the AC hall, you are enjoying the coolness in your body. When you are hearing a music, you are enjoying by ear. But mathematics, this is another enjoyment you can enjoy by your brain, by your this one. This intellectual happiness is the most beautiful and happiness in the world. So that mathematics will give you. Any understanding or knowing, getting knowledge is always this intellectual thing, and mathematics is more thing. So whatever problem in mathematics you have, suppose in class teacher is giving you a problem, you consider this as a puzzle, like a Sudoku, something. Then you get interest in it, solve it. Then you will feel happy. I have solved a puzzle. I have won the game, like that. Then if you get the enjoyment, then that will create more interest in mathematics. Then mathematics become easy to you. So that is that. Finally, I want to tell you, if you want to make mathematics easy and want to get good marks in this subject, learn how to enjoy mathematics. Okay, that is a proper way of learning mathematics. When you are doing the problem, then you are listening the mathematics class, forget about the exams, forget about what others are going to do, whether you are enjoying it. See how to enjoy this one. So then mathematics become easy. So how to create that enjoyment in mathematics? This kind of programs. Your school is conducting a very nice program. I am really very happy about it. This kind of programs are best way to the students to know how to enjoy mathematics. I am very sure that almost all the students in this school now feel mathematics is more interesting than before. After this 1 week program, they see how mathematics is interesting. We can sing mathematics. Some boy is singing mathematics. Somebody is dancing mathematics. Okay, and one boy, I think he is Ramesh. He is doing triangles in a circular disc using the thread. He is proving some results on triangles. That's I forget his name. Sorry. It's wonderful. Such kind of activities are more interesting. And Jehu, another small boy using that acute triangles, something. So small instruments, using instruments, he is doing some mathematical experiments. Okay, that kind of activities. You need not wait for an exhibition to come. So each week you may allot some hour to speak some interesting thing about mathematics. I will definitely tell that your marks will improve. Your interest in mathematics will improve. That implies your marks. Then your result, you will get a good result. Okay, you will have a good future. So get interest in mathematics. If you know how to read mathematics and other things, other physics, chemistry, other subjects also become easy for you, because mathematics teach you how to learn a thing. Okay, so that is why in school level all of you are compulsorily having mathematics. Okay. So yeah, so that now once again I'm telling that you people are already got more interest in mathematics. This is the real success of this program. Yeah. So I appreciate very much the school administration and the principal and the teachers organizing in it, and the students who involved in this program, and their involvement of conducting the involvement and their effort in conducting this program in a grand manner. Okay, so once again I thank you very much for inviting me to this function as a teacher of mathematics and also a student of mathematics. I am very happy to attend this function. So thank you very much. I may have more opportunities to contact with you. Maybe after this pandemic situation, we will face each other and we will discuss more mathematics, and we both learn mathematics together. Okay, thank you very much.
Thank you, sir, for that motivational speech. Now I request our principal to come and say a few words.
A very good morning to one and all present here. Respected Chief Guest, Dr. T. Dureved, my dear parents, teachers, students, and all the viewers for this grand finale of KYMIP 2020. When my teachers said that they would like to, have a live event for the exhibition in mathematics, I was a little puzzled actually, sir. I wasn't sure whether this is going to take place or not. I was thinking, how can we do this? Already we are having a very difficult situation as well as mathematics, and going on air. How can we do that? But today I realized that it was possible, and that is what it is in our school. All our teachers and students make things that is impossible possible. I'd like to thank you in a very special way, sir, for coming here as a chief guest and being here with us for so many projects that the children have been saying. And I hear that that you would like to stay for the entire show. I was wondering whether I'm keeping you over here. That's why I asked you to speak, so that if you are busy, you could go. But I was so surprised that you would like to stay for the entire show. I'm so happy, sir. Sir has been, the head of the department in Pondicherry University. Right now, he's working in another particular college, and I'm so happy that, sir, you could be here. He has been the professor and Department of Mathematics and coordinator, 5 years integrated MSc program in Ramanujan School of Mathematical Sciences. Sir knows our school very well because he was former HOD of Mathematics Department, Pondicherry University, and his area of specialization is commutative algebra. And I like the way you said, sir, that mathematics is actually a truth. And I was very surprised with that, because that's very true. Now thinking of it, Really, everything that is said is truth, because many of the other sciences keeps disapproving the other theories and coming up with new theories. But when it comes to mathematics, it is a language that is of a truth which is unchangeable. It is called pure truth. That is something that I'm taking home from your message, sir. It is a rule book of universe. That is what is another take-home message that I'm taking from you, sir. It is a rule book of the universe. That is what is mathematics. I'm so happy and glad, sir, that you have asked the children that with the study of mathematics to have critical thinking, to think properly, to see that we will be able to enjoy mathematics. And that is why we have held up this particular function. We do a lot of things, sir. This entire week, I will ask Prabhu to share with you the small activities right from kindergarten, how we have been motivating the students to enjoy mathematics through whatever they see, whatever they look around, the people that they meet, the lectures that they hear, whatever it is, you can see the beauty of mathematics in it. And that is why we keep on telling the students that mathematics is not a tough subject. People shiver when they hear the word maths. They don't like to, take up mathematics, and many of the students drop out mathematics when they come in to the 11th standard. But they should realize that mathematics is a beautiful subject. When you go inside, you realize that problems are not problems. They are they can be enjoyed. Thank you so much, sir, for bringing out these beautiful truths for us, because it is really actual truth, mathematics is. So thank you so much for being with us here. I'd like to also thank the Department of Mathematics, heading Prabhu sir, for his passion that he is trying to convey to the other students, that the passion that he has in mathematics can be conveyed in different ways. Thank you, Prabhu sir, for this beautiful arrangement of programs, and the entire department, Mr. Edison, Ms. Esther, Ms. Pragya, Ms. Vinolia, Ms. Sindhuja, Ms. Shirley, as well as the entire teachers in the primary block. They all are mathematic teachers. They do take all the other subjects, but they also give the foundation for mathematics. In fact, the NEP 2020 also says that we have to give them, the pre-kindergarten, the early childhood care education also should give them an understanding of mathematics, how it is related with time, space, money, shapes, or whatever it is, so that they will be able to enjoy mathematics. So this is what the primary group of teachers are doing, though they are not specialized in the subject, but they love mathematics and they give the foundation for it. So all the hats off to the entire primary group of teachers for bringing out beautiful activities that I enjoy watching in your groups that you have been posting. Also the technical team that has been present over here, Mr. Suresh, Mr. Satya, Rita and Teresa, and also a student that has to be mentioned, Srivatsan. They have brought this whole program out. Otherwise, in this particular pandemic, it is not possible for us to have an exhibition. And it is because of the technical team in our school, once again naming them, Suresa, Satya, Rita and Teres and Srivatsan, who came together to bring this particular event on air. Thank you so much. And thank you all my dear parents and students for cooperating with this entire team of teachers and bringing out, giving your time, bringing out beautiful videos. In fact, now all my students and parents and teachers have become special, in bringing out videos. It was earlier something that was a novel idea, but today I can see all my students can make a small video for any type of a topic. So thank you parents, thank you teachers, and thank you students for all the efforts that you have done in this particular program. Thank you once again. Once again, thank you, sir. I would like you to continue staying over here and watching our entire program. I think it goes on till 11:30. We're going to put it up on YouTube also. Many projects have come in, so it will be an online program for the whole day, but we will be ending the program at 11:30. 12:30. At 12:30, we'll be ending the program and we'll also be putting it up on YouTube. Thank you, everyone. Thank you, sir. Thank you very much.
Thank you, ma'am, for all your words. Continuing with the program, now we have our 10th graders with the mathematical skill.
Once upon a time, in a classroom during a break, a really hyperactive girl was waiting for her friend Veda. And where is that girl? For God's sake, please chill.
Guys, guess what our topic is for the assignment? Wait for it.
Can
you believe it? Oh my god, I'm so excited.
So,
Well,
why would we actually do math? It's so hard and boring, and it just annoys me most of the time.
okay, come on, stop exaggerating.
Come on, guys, what are we waiting for? Let's start.
Guys, OMG, drunk of COVID. This is amazing. I mean, it's horrible. It sucks.
Stop wasting time now. Let's get started.
Okay, guys, I know math is hard, but if we don't finish it soon, we will die.
Yes, let's do it. I have every single thing ready.
No way, not happening.
See now, I knew this would happen. So, I brought in a few friends of mine to show you that maths is not boring. Come on in, guys.
Hey guys, let us know more about the butterfly effect theory. So the butterfly effect theory holds a basic concept where a butterfly in Brazil is able to cause a tornado just by flapping its wings in Texas. Well, it doesn't make any sense, right? But yeah, this is the basic concept. So this theorem is usually used in modern chaos theory to support the fact that a minor thing can have a major impact in large complex systems. So this was actually discovered by American meteorologist and mathematician Edward Norton Lawrence. He discovered it accidentally. So how did he discover it? So first, when he was running a weather simulation, he initially entered the value up to 6 decimal places. And the second time he thought, these values are so negligible. So this time, he entered the decimal value up to only 3 decimal places. When he noticed the results, they were so drastic and the graph was unrecognizable. So this is where he interpreted to himself that sensitive dependence on initial conditions are really necessary. So to support this theorem in modern times, we can do it with a simple experiment. So for this, we would need at least 2 simple pendulums. So we need to make sure that these two are exactly identical and similar, and they should be done in the same place under the same conditions. So when we move out the bob, initially they would carry out the same pattern, but we would never be able to find out the results. This is because we would not be able to find the minor impacts on such experiments. So hence, the butterfly effect theorem proves out to be really important in modern society.
In mathematics, two quantities are said to be in the golden ratio if their ratio is the same as the ratio of the larger of the pieces. If you are not able to understand that, here's a simpler one. Golden ratio is the ratio of a line segment cut into 2 different pieces of different lengths such that the ratio of the longest segment to that of the whole segment is equal to the ratio of the shortest segment to that of the longest segment. This ratio is 1.6:1, which is represented by the Greek letter phi, which also has a value of 1.618033397. This ratio is crazy. You've probably seen it every day, and you won't realize.
Hello everyone. I'm going to talk about the Fibonacci sequence. So the Fibonacci sequence is a series of numbers or in which you can get the next number by adding the 2 numbers before it. So the series is as follows: 0, 1, 1, 2, 3, 5, 8, 13 and so on. So when you add 0 and 1 you get 1, 1 and 1 you get 2, 2 and 1 you get 3, 3 and 2 you get 5 and so on. So it's a very simple and very fascinating sequence. You can also obtain the golden ratio when you add the 2 successive Fibonacci numbers. You can also find a Fibonacci number using the golden ratio. I've got one more interesting fact here. 23rd of November is noted as the Fibonacci day because you can write 23rd November as 1123, which is a part of the Fibonacci sequence.
Okay, this project may actually be kind of fun.
Yeah, actually this stuff made me put down my phone for a second. Believe me, no one can do that.
Oh, you do your thought homework?
The game which we have showcased through this kit has increased the percentage of our profit in maths. Even if you stumble, make a step that the crowd cheers for. Now we have the 6th standard students with a dance. Thank you, folks. Your dance gave rhythm to my heart. Let's now understand the geometry of maths.
Hello everyone, I'm Shruti Prabha from class 11 and today I'm going to be explaining about the most beautiful equation in math. The most beautiful equation in math is nothing but Euler's identity, which is e to the power of I pi plus 1, which is equal to 0. Euler's identity is amazing because it is simple to look at and yet incredibly profound. The equation combines 5 of the most important numbers in mathematics: e, pi, I, 0, and 1. So first, I'd like to explain about pi. Pi is defined as the ratio of a circle's circumference to its diameter. Pi is the 16th letter of the Greek alphabet and it is an irrational number. So the value of pi here is 3.14159, and so on. Here I have it up to 50 decimal places. So next is iota, which is commonly referred to as I. So before I explain what is that, I'd like to explain what a complex number is. A complex number is a number that can be expressed in the form of a plus I into b, where a and b are real numbers. A is called the real part and IB is called the imaginary part. I is the square root of -1 and it's an imaginary number. So first of all, why does I exist? Because it's just an imaginary number, so why do we even need it? Well, I'll explain here with an example. So take any function f of x. For example, x squared plus 1 equals to 0. But here we can see when we find the discriminant b squared minus 4ac, we get the result as less than 0, which means that there will be no real roots. So we have to use the complex number system and we cannot use a real number system. So from that, if we use I, we can conclude that x is equal to 0 plus or minus I. At last, we have Euler's number, which is E, and E is a mathematical constant related to exponential growth and rate of change. So it's an irrational number. Now, why is E related to growth and rate of change? So for that, let's look at the original problem where E was first used. So we're going to go back to the 17th century, and this is Jacob Bernoulli, and he was interested in compound interest, so earning interest in your money. So imagine you've got £1 in the bank, and just so you know, £1 is equal to 95 rupees. So, and you have a very generous bank, and they're going to offer you 100% interest every year. So that means that after 1 year, you would have £2. So what if I offered you instead 50% interest every 6 months? So you're starting with £1, and after 6 months for 50% interest, you would get £1.50, and another 6 months, 50% of that would be 75p, which would give you a total of £2.25p. So it's actually better. In fact, the more frequent your interest is, the better the results. So let's start with every week. So you would multiply your original £1 into 1 plus 1 by 52, which is your interest. And for 52 weeks, you would raise it to the power of 52, which would give you £2.69. So in general, we can write it as 1 plus 1 by n whole power n. So if we take it further and do it for every day, we would get 1 plus 1 by 365 whole power 365, which would give £2.71. So it would get even better if we could do it for every second, every nanosecond, for every instant. Then it would be continuous interest. What would that look like? Now, if I use the formula 1 plus 1 by n whole to the power of n and let n tend to infinity, then what would that value be? That is what Bernoulli wanted to find out. He knew it would be between 2 and 3, but he didn't get it. So 50 years later, Euler worked it out. And that value was 2.71828 and so on, as you can see here. Now Euler proved that this was irrational by using this formula, which you can see here. E is equal to 2 plus 1 by 1 plus 1 by so and so. So there's a pattern here, which is 2, 1, 1, 4, 1, 1, 6, 1, 1, and so on. And that pattern does hold. So this fraction is a continuous one and it never ends. So which means the decimal expansion would also never end, and hence it's irrational. Okay, now why is E a big deal? It is because E is a natural language of growth. Now we have a graph here, y is equal to e to the power of x. Now if we take any point on that curve, the value of that point would be e to the power of x, the gradient and the area would also be e to the power of x. So in the next graph, if we substitute x is 1, the area, value and gradient, all of them would be equal to 2.71. And that is why E is very special. Thank you.
Hello everyone. I welcome you to enjoy the Math Week Know Your Math in Pandemic 2020. I am Nirusha from Class 10A, and today I'll be presenting you with an interesting conjectures in mathematics which has brought a sense of bewilderment among mathematicians for decades, the Collatz conjecture. So we all know that a conjecture is a mathematical or scientific theorem which has an incomplete conclusion. So here we'll be dealing with one such conjectures. Collat's conjecture demystified. So before we get started, let's see if you can guess what the image is right over here. Well, I hope at first glance you would assume it to be an object such as a feather or a yarn, etc. Well, it's not exactly an object, but what it is indeed is a number graph of the conjecture in the programming language of Java. Well, it's a compilation of the numbers of the Collat sequence in a graph. So now let's see what exactly is Collat's conjecture. The Collat's conjecture is one of the most perplexing conjectures in mathematics, which deals with a sequence which follows a specific rule. The rule states that if we take any positive integer, say n, the number succeeding it would be 3n plus 1 if n is odd, or it would be n by 2 if n is even. The result is that whatever may be the value of n, the sequence would eventually end with the number 1. So what would happen once we reach down to 1? After 1, the sequence follows a loop, that is an infinite loop with the numbers 1, 4, 2, and it gets repeated 1, 4, 2, and so on. This conjecture was initially proposed by German mathematician Lothar Collatz. Hence, the conjecture was named after him. So it's always, sometimes called as the Euler's conjecture, Haas conjecture, or the 3n plus 1 problem, etc. It is named so after the mathematicians who have rigorously worked on them, but still, they could only provide us with partial results. So now let's see the exact problem of the Collat's conjecture, the Collat's conundrum. So in this slide, we are able to see few numbers. Well, they aren't just numbers, they follow the Collat sequence. Here, we would be able to see 1. And so, after 1, we have the infinite loop, 4, 2, 1, and it goes on. Now, it might see such an easy problem, but you might wonder, why is it unsolved yet? Well, I'll explain that to you in a moment. So now, we are able to see a number tree. Well, it follows the sequence of the Collat's conjecture. Moreover, it's a common pathway for most numbers following the sequence. Here, we can see that we eventually reach down to 1. After 1, we once again move on to 4, 2, and 1. And hence, it's proved. So now let us try to prove it ourselves. Now, for example, let us try to verify if the number 99 follows the Collat's conjecture or not. Well, since it's odd, I start with the formula 3n plus 1. That is 99 multiplied with 3, and I add 1. So the result is 298. Since it's even, now I have the number. I get 149. Now, I'm going to apply the same rules again. And what I'm trying to prove here is that I must reach down to 1. And once we get 1, we are going to try to formulate the same method again, just to ensure that we reach the infinite loop of 4, 2, and 1. So now we got 1. After 1, I'm going to apply the same rules. Now 1 multiplied with 3 plus 1. So again I get 4, and after 4 I get 2. And we reach down to 1 once again. And hence we can prove that the number follows the conjecture, and the result is the formation of the loop 4, 2, 1, and it goes on. This is the sequence of the above example. So now let's see why exactly is the Collat's conjecture unsolved. So far we are not aware of the total number of positive integers that might even exist, and moreover there are a lot of decimal positive integers, and hence they reach down to number 1 or a number closer to 1, and still it does not exactly prove the Collat's conjecture. Moreover, a few numbers may reach down to 1, but still some of them march off to infinity. So now let's see the recent advancements made on the Collat's conjecture. So in 2019, Australian-American mathematician Professor Terence Tao made a further advancement of the Collat's conjecture by using partial differential equations to prove the conjecture. Well, he is still aware that we can never prove it 100%. Now what we can do is that we can provide the resolving of the conjecture. Well, being said that, it is a prototype of a dynamical system involving the state space as the positive integers. Now, we can hence expect partial results, which helps us to create counterexamples to disprove the theory. So in 2017, the conjecture was verified up to 10 to the power 20 places. So one way to disprove the conjecture is that an infinitely recurring loop other than the loop 421 must be discovered. And if in case such a cycle is discovered, it must be of the length of at least 17,087,915 digits. So far no such argument has been discovered, and hence, as of now, the conjecture has neither been proved wrong nor proved right. So I would like to end my speech by saying that every solution of a problem raises new unsolved problems. Hence, the path for eternal knowledge is demystifying them. Thank you for joining us today.
Hello everyone, I am Krishna Sweta from 6th CL and I am going to tell about symmetry. Symmetry is defined as a balanced and a proportionate similarity which is found in two halves of an object. That is, one half of an object is just the mirror image of the other half. An imaginary line or axis along which we can fold an object into two equal halves is known as line of symmetry. A line of symmetry can be vertical, horizontal or diagonal. The four main types of symmetry are translation, reflection, rotation and glide reflection. Symmetry is used in calculations of sphere, equilateral triangle, isosceles triangle, circle, etc. Let us look at some examples. This line of symmetry separates this butterfly into two equal halves. This line of symmetry separates this leaf into two symmetrical halves. This line of symmetry separates this ladybug into two symmetrical halves, and this line of symmetry separates this house into two equal halves. Thank you.
Hello everyone, I am Dinesh of grade 12. Now let us make the dynamic model of three-dimensional coordinate planes with 8 octants. For making this model, we need 3 square cardboard sheets of same size. If the edges are rough, make them smooth using colorful tapes. In this way, our 3 planes are ready. Now take one plane and mark the midpoints of each side and join the opposite midpoints. Now these are the 2 axes of the plane. Now mark the measurements starting from origin as shown in the image. Do this for all the 3 planes on both sides. Now take 2 planes and cut through any of the axes up to the center or origin. Now take the third plane and divide it into two equal halves from one of its axes. Now cut both the parts up to the half to its axes. Now cut one axis of one of the previous plane 1/4 from the top and 1/4 from the bottom, as shown in the image. Now fix all the 3 planes perpendicular to each other using the slits cut on them, as shown in the image. In this way, our 3-dimensional coordinate axis in which 3 planes intersecting each other at right angle with 8 octants is ready. Now let us find the coordinate point of coordinate of point P, which is vertex of the cuboid. On observing the edges of the cuboid, we can easily find the x, y and z coordinates of point P, which are 2, 4 and 6 respectively. Thank you.
Here comes a 10th grader to create a bond between math and hip hop.
Me and my friends at the table, so looking fast, I used to be slow. Come over and try to come to me. Trust me, still in the charm, it's now take a pencil. About to tell my jukebox, the memory start to dance. Sing like go, you know I love these songs. Come on, so handmade for some I like it. Coming out for melody, I am the crazy groove. She said, boy, we struggle far too much. Running and compensating, carrying what's coming out for melody. Coming out for melody.
Thank you for that upbeat dance. Now, Archie, allow me to take them to the same world of math that you took them to.
Hello everyone, my name is Vasha and I'm from class 10C. Today I'm going to be relating a type of art which is named as Zentangle to math. Before that, let's see what is this. A Zentangle is a miniature abstract work of art made from designated Zentangle patterns, usually repetitive patterns that involve only a few types of strokes. Zentangling is a form of art meditation and is similar to mandala. Interestingly, many of the Zentangle patterns involve mathematical principles. Here I have explored such two patterns. The first one is the tipple pattern. We all know what an infinite series is. An infinite series is a series of an infinite number of terms that follow a pattern. As more number of terms are added, the sum of the terms gets closer to a number. This number is the limit. But what does this have to do with entangles? In this triple pattern, different size circles are drawn. Say you decide to draw the triple pattern and you want to leave the least white space in between the circles as possible. You line some larger circles up in a grid and then draw circles about half of the size in the white space left. Then you draw circles half of that size in the leftover white space and you continue this. Eventually, you will be unable to draw more circles. But if you could draw perfect circles and very small circles, then there would always be white space left. The circles would continue to decrease in size by half. Because of this, the triple pattern behaves in a very similar way to an infinite series. Now let's put them in numerical terms. Say the area of the first circles, that's the biggest circles, is 1. The area of the next smallest circle is half. Next smallest 1 by 4 and it goes on. If you only look at one of each size circle, then the total area of these circles would be 1 plus half plus 1 by 4 plus 1 by 8 plus 1 by 16 and it goes on till 1 by infinity. This total area number would get closer and closer to 2 but never hit it. Therefore, the limit is 2. This is the same idea as Zeno's paradox. In addition, this pattern can be used to make a fractal. Here, the next pattern is the Rick's paradox pattern. We all know what a straight line curve is, just like it sounds. We can create straight line curves using straight lines if we draw the straight lines in the same angle. In this image, if every straight line is drawn at the same angle, then D will be the same distance in between each line. In this case, Because there are four sides, there will be four curved lines. How can it be used in a rectangle? In this Rex paradox pattern, straight lines are used to make curved lines. In this example, which we saw before, the original shape is a triangle, which has three sides. So the result is three curved lines. The curved line seems to be in a spiral in the from the center. This is called a logarithmic spiral. Each curved line that reaches from one corner of the original shape to the center of the spiral is the length of one side of the original triangle. Thank you, and I hope that you would have understood the relation of some patterns of Zentangle.
Everyone, we are the students of 10th and we are going to prove the relation between the cone and the cylinder, which is nothing but pi r square h is equal to 1 by 3 pi r square h. We shall prove it both in theoretically as well as practically. First, let us prove it in theoretically.
Mathematically, that 1 by 3 volume of a cylinder is equal to volume of a cone. Proof. Radius of the cylinder is equal to 3.8 centimeter. Height of the cylinder we assume that 16 centimeter. The formula for cylinder is equal to pi r square h. Now we substitute all the values. Pi is equal to 3.14 into 3.8 square into 16, which gives us this value. 1 by 3 volume of a cylinder is equal to 1 by 3 into 725.46, which gives us this value. Therefore, volume of a cone is equal to 1 by 3 volume of a cylinder. Hence, prove.
Prove it practically for better understanding.
Now, let's see how we can experimentally prove that the volume of cone is equal to 1 by 3rd of the volume of cylinder. Experiment, the required materials are cardboard, chart, pencil, ruler and glue. Let's move on to the experimental proof. For this, we need to make a cone and a cylinder with the same height and radius. Now, let us see the making video of cone and cylinder. Come on, now let's prove it. We must fill the cone with sand and transfer it to the cylinder. We must repeat this step for 3 times. Here you can see that by the 3rd time we have filled the cylinder. Hence, we have proved that the volume of cone is equal to 1 by 3rd of the volume of the cylinder.
I hope you enjoyed it and a happy Max Week. Thank you.
Good day everyone. This is Lakshan from 9E. This is my project, the COVID-19 predictor. This helps us predict the rate of increase of coronavirus in India. It creates awareness and prevents us from being careless. Now we will see the working model of my project. Now I am going to tell you how I calculated the prediction. First, I took the rate of increase of coronavirus cases in each week in the month. Similarly, I took it for all the months. Then I calculated the average. After that, you will get your derivation. Thank you.
Hi friends, I am Timo from 7th A. This is the circular football ground. The man stands at the center of the circle. It is called a center. When the man 1 kicks the ball to man 2, it is called as radius. Now the man 2 kicks the ball to man 3, it is called as diameter of the circle. When the man 3 kicks the ball to man 4, it is called the chord of the circle. Now we can see people passing the ball in the football ground. The outer area of the circle is called as circumference. The inner area of the circle is called as area of the circle. Thank you. Bye.
Lines and Angles by S. B. Ritika from 70. The aim of this project is to make everyone understand about different lines and different angles. First now let's see about lines. Parallel lines. Two lines in a plane which do not intersect each other even if it is extended indefinitely in either direction are called parallel lines. Distance between two parallel lines is same everywhere. Line M is parallel to line N. Transversal lines. A line which intersects two or more lines at a plane at different points is called transversal line. Here, line P is a transversal line. Intersecting lines. Two or more lines which intersect each other at a point are called intersecting lines. Your line R is perpendicular to line S. Collinear points that lie on the same line are called collinear points. Non-collinear points which do not lie on the same line are called non-collinear points. Now comes angles. Acute angle which is greater than 0 degree but less than 90 degree is called acute angle. Right angle which is exactly 90 degree is called right angle. Obtuse angle which is greater than 90 degree but less than 180 degree is called obtuse angle. Corresponding angles which correspond each other as they are similarly placed are called corresponding angles. Corresponding angles are equal. Angle 1 is equal to angle 5, angle 2 is equal to angle 6, angle 4 is equal to angle 8, angle 3 is equal to angle 7. Interior angles. Angles which have only one common arm and lie between two given lines are called interior angles. Here, angle 4, angle 5, angle 3 and angle 6 are interior angles. Some of same side of interior angles are supplementary. Exterior angles which do not have one common arm and do not lie between two given lines are called exterior angles. Here, angle 1, angle 8, angle 2 and angle 7 are called exterior angles. Some of same side of exterior angles are supplementary. Alternate angles. Alternate interior angles are equal. Angle 3 is equal to angle 5, angle 4 is equal to angle 6. Alternate exterior angles are equal. Angle 1 is equal to angle 7, angle 2 is equal to angle 8. Vertically opposite angles. When two lines intersect each other, the vertically opposite angles are equal. Here, angle 1 is equal to angle 3, angle 2 is equal to angle 4. Linear pairs. Two angles are said to be linear pair if they are adjacent angles formed by two intersecting lines. Angle 1 and angle 2, angle 2 and angle 3, angle 3 and angle 4, angle 4 and angle 1 are linear pairs. Some of linear pairs are supplementary. Thank you for listening.
Hello everyone, I'm Sucharita from 8th EL.
And for this Maths Week, I have created a working model to demonstrate Pythagoras' theorem. In this model, there is a protractor that shows the angle, the thread that shows the hypotenuse, and the lift that shows the height. When the lift goes up, the hypotenuse increases, and as the lift goes down, the hypotenuse decreases. We all know that a square plus b square equal to c square. This is one of Pythagoras' famous theorem. Here, a is the length, b is the height, and c, which is the hypotenuse. Thank you.
This is Tamararpan of grade 9. I am here to do a maths portfolio project. From our early classes, we have just calculated with the values given in the book. But now we are going to do a live experiment on surface area and volume. The main aim of the project is that how many dosas are required to fill the cylindrical vessel, with given that both the dosas and the cylindrical vessel's radius are equal. Here, now we will calculate the volume of the cylindrical vessel and volume of the dosas. This is diameter of a cylindrical vessel. Now, we are going to calculate the volume of the cylindrical vessel. The volume of the cylinder is pi r square h. Radius 5.5 cm, diameter 11 cm, height and 11 cm. Now we are going to calculate the volume of the cylindrical vessel. Volume equals pi r square h. So that while we calculate, we will get 1045 cm cube as the answer. This is the volume of the cylindrical vessel. Now we are going to calculate the volume of the cylindrical dosa. Volume of the cylinder pi r square h centimeters cube. Radius equals 5 cm, diameter equals 10 cm, height equals 1 cm. Now we are going to calculate the volume of the cylindrical dosa. Volume equals pi r square h. While we calculate, we will get 78 cm cube as the answer. So the volume of the cylindrical dosa is 78 cm cube. Now to find how many dosas are required to fill the cylindrical vessel, we shall divide volume of cylindrical vessel by volume of cylindrical dosa, so that while we calculate, we get 13 as the answer. So 13 dosas are required to fill the cylindrical vessel. Now we are filling this cylindrical vessel with a dosa. And yes, hence proved.
Hello everyone, this is Niranjana.
This is Manushree.
For this Maths Week, we are here with the answer for the unanswered question that lies in every student's mind. Is it true that some people just can't do math?
Well, we'll find out.
How does the mind work? And especially, how does it learn? Even knowledge serves as well. But is there anything sturdier to rely on? Of course, yes. Cognitive science is an interdisciplinary field of researchers from psychology, neuroscience, linguistics, philosophy, and anthropology who seek to understand the mind. Through cognitive science, we'll try to reach a conclusion.
So, what does nature provide? Humans have a clear proclivity to learn some types of information. The most notable example is language. Given normal linguistic input, virtually all children learn their native language without effort or explicit instruction. Is something comparable true of mathematics? Just how naturally do students learn mathematics? Two important findings from the last 20 years are relevant. Humans are born with the ability to appreciate the concept of numbers, and humans seem to be born with the sense that number and space are related. First, humans are born with two ways to appreciate numbers. One is approximate number sense. Second, number and space are represented in overlapping areas of the brain. So it appears that humans are born with a sense of numbers as spatial, but the space is not linear. So what comes naturally to children in maths? They have a natural sense that allows them to understand and manipulate very small quantities with precision and much larger quantities in approximation. Those abilities are, of course, a far cry from the abilities the teachers hope to develop in their students, but they are the base upon which the teachers must build. We should keep in our minds that students are born with the ability to learn math, and we should not let them giving up and concluding by saying that they're just no good at math.
So, what do students need to be successful in math? In its recent report, the National Mathematics Advisory Panel argued that learning mathematics required three types of knowledge: factual, procedural, and conceptual. So, let's take a close look at each. Factual knowledge refers to having ready in memory the answers to a relatively small set of problems of addition, subtraction, multiplication, and division. First, it is clear that before they are learned automaticity, calculating simple arithmetic facts does indeed require working memory. Second, students who do not have maths facts committed to memory must instead calculate the answers, and calculation is more subject to error than memory retrieval. Third, knowledge of maths facts is associated with better performance on more complex math tasks. Fourth, when children have difficulty in learning arithmetic, it is often due in part to difficulty in learning or retrieving basic math facts. Somewhat more controversial is the relative emphasis that should be given to these two types of knowledge and the order in which students should learn them. Conceptual knowledge sometimes seems to precede procedural knowledge or to influence its development. Then too, procedural knowledge can precede conceptual knowledge. A third point of view is that for most topics, it does not make sense to teach concepts first or to teach procedures first. Both should be taught in concert. Indeed, this stance seems like common sense, right? Since neither procedures nor concepts are as quickly and reliably in most students' mind without significant prompting, why wouldn't them in concert?
Yes, I do agree with your point. Studies state that students lack conceptual knowledge. Unfortunately, of the three varieties of knowledge, it is the most difficult to acquire. This is because knowledge is never acquired from the beginning. A teacher cannot just pour concept into the students. Rather, new concepts must build upon something they already know. Examples are so important while introducing into a new concept. Learning new concept depends on what we already know. So how can students learn concepts? Manipulatives seem helpful as they are concrete. It is always better to illustrate real life examples as familiarity is also a key to understanding. Familiarity helps because it allows to prompt students to think in new ways. Familiarity is not the only necessary ingredient for successful examples. Students are more likely to understand abstract ideas when they see more examples. This helps them to learn new concepts. As concepts become more complex, teachers tend to use analogies. Ways to make analogies more effective are making it familiar, making it vivid, making the alignment plain, and continuing to reinforce the analogy.
What does all this mean for teaching? First, you should think carefully about how to cultivate conceptual knowledge and find an analogy that is suitable across topics because it is useful for students to use a single analogy to which they are written again and again. Drawing connections among mathematical topics deepens conceptual knowledge. Procedural and factual knowledge are equally as important as conceptual knowledge. Conceptual knowledge without procedural or factual knowledge is ineffective. Tie conceptual knowledge to procedural knowledge so students learn how as well as why. The key to become a good problem solver is bare competence with facts and procedures. Next, in teaching procedural and factual knowledge, ensure that students get to automaticity. By explaining the automaticity with procedures and facts, it helps the students with their mind to think about concepts. For better factual knowledge, students must know all basic math facts. Next, choose a curriculum that supports conceptual knowledge. Conceptual knowledge is indeed difficult, so it makes sense to study few concepts each year, but in depth sequence topics as much as possible. Next, don't let it pass when student says, I'm just no good at math. We hear it a lot, but it is rarely true. It may be true that some people find it difficult than other subjects, but with some persistence and hard work, the students can learn math.
In conclusion, as Benjamin Franklin said, an investment in knowledge pays the best interest. Through this session, we are glad that we introduced you to a new angle for approaching math. We encourage everyone to learn math and not study math. I hope you all enjoyed the session. Thank you for listening.
Here comes Edison Sir to capture our minds with his vocal cords.
Let me tell you math story, pay attention, listen to me.
என்ன சார் மேத்தா?
Just listen bro. Sin square a plus cos square a equal to 1 baby. 6 square a minus tan square a equal to 1 baby. 1 plus cot square a. Oh 6 square a. These are all trigonometry. Identities baby. Together man. Sin square a plus cos square a equal to 1 baby. 6 square a minus tan square a equal to 1 baby. 1 plus cot square a. Oh 6 square a. Designer. Problems will come and go. இதை apply பண்ணு மாப்பி. No tension, baby. Sin 2a is 2 sin a cos a. 2 cos square is 1 plus cos 2a. Oh, 2 sin square is 1 minus cos 2a. Cos square a minus sin square a. Cos 2a baby. Sin 2a is 2 tan a by 1 plus tan square a. Tan 2a is 2 tan a by 1 minus tan square a. Sin 3a is 3 sin a minus 4 sin cube a. Cos 3a is 4 cos cube a minus 3 cos a. Formulas easy Nanba, always be happy. Many problems will come and go. இதை apply பண்ணு மாப்பி. Students, sin a plus b plus sin a minus b 2 sin a cos b baby. Sin a plus b minus sin a minus b 2 cos a sin b baby. Cos a plus b plus cos a minus b 2 cos a cos b. Cos a plus b minus cos a minus b minus 2 sin a sin b. No tension, baby. Sin c plus sin d is equal to 2 sin c plus d by 2 cos c minus d by 2. Sin c minus sin d is equal to 2 cos c plus d by 2. Sin c minus d by 2 cos c plus cos d is equal to 2 cos c plus d by 2 cos c minus d by 2. Cos d minus cos d is equal to 2 sin c plus d by 2 sin d minus d by 2. Sin a cos b plus cos a sin b sin a plus d baby. Cos a cos b minus sin a sin b cos a plus b baby. and lost time. Tan A plus B is tan A plus tan B by 1 minus tan A tan B. Cot A plus B is cot B cot A minus 1 by cot B plus cot A. Math is easy, Nanba. Always be happy. Designer, problems will come and go. இதை apply பண்ணு மாப்பி. That was my math story. How was my math story? That was my math story. How was my math story?
Just awesome, sir.
No tension, baby.
Thank you, sir, for that amazing trigonometry song. 1 becomes 2, 2 becomes 4. And now comes another group to take the dance floor.
सावली सलोनी अदाएं मनमोनी तेरी जैसी ब्यूटी किसी की भी नहीं होनी ठंडे की बोतल में तेरा अपना गति से कट कट मट्टी लो कोका कोला तू शोला शोला तू कोका कोला तू शोला शोला तू
That was an earth-breaking performance. Now to exhibit our exhibit, here comes an exhibitor to exhibit our show.
A warm welcome. Today, Sanfri and I are going to present the topic Arithmetic Progression in Daily Life. Let's go ahead and see a few examples based on arithmetic progression. So what is arithmetic progression? Arithmetic progression, also called as AP, to put in simple words, is a sequence of number which has the same common difference. Take any series of number and the common difference between any two successive terms is going to be a constant value which is equal, then you call it an AP. The general form of AP. The general form of AP is A plus D, A plus 2D, A plus 3D, and it goes on. The general form of AP is obtained from the formula for finding the nth term of an AP, which is AN is equal to A plus n minus 1 into D, where AN stands for nth term, N stands for number of term, and D stands for common difference. Substitute any one value for n, say A5, which is A plus 5 minus 1 into D, where A5 is equal to A plus 4D. Taking an example given below, A1 is equal to 1, A2 is equal to 3, and A3 is equal to 5. And the common difference between any two successive terms is going to be similar, you call it an AP. So A3 minus A2, which gives you 2, and A2 minus A1 also gives you 2, which means the common difference is a constant value, so it's an AP. Now, examples. Stacking cups, bowls, or even chairs. The criteria which we use behind this is the number of object or the height of the object. Talking about saving schemes, most of us deposit money in the banks, which eventually earns an increment or an interest to it. Say you deposit 1000 rupee, you earn an increment of 50 rupee at the end of a year, which would make an AP of 1000, 1050, 1100, 150, which makes an AP with a common difference of 50. Talking about the seating arrangement in theaters and auditoriums would also make an AP. If you observe, the first row may have 3 seats, the second row may have 5 seats, and the third row may have 7 seats. The fourth row may have 9 seats, which also makes an AP of 3, 5, 7, 9, 11 with a common difference of 2. Talking about your taxi fare. The taxi fare has a fixed charge. For the first kilometer, it might cost you 12 rupee, and for the next subsequent kilometer, it might cost you 6, which means 12 plus 6, that is 8 plus D. Then 12 plus 2 into 6, that is 24, and then 30, which also makes an AP of 12, 18, 24, 30, 36 with a common difference of 6.
So let us start from evolution. The theory which claims that we human beings evolved from apes and our ancestors were apes. However, the evolution of human beings did not mark the beginning of arithmetic progression. Arithmetic progression must have been present before the Big Bang theory because it's a part of math. So coming to the first generation of apes, which has undergone a bit of evolution. So you could see that this ape has a really big hunchback, due to which the length of the backbone must have been really less. Let us consider the length of the backbone of this ape to be 30 centimeters in height. And the second generation of apes, which has undergone a bit of changes, to be 40 centimeters in height. And the third generation to be 50 centimeters in height. And then the fourth generation to be 60 centimeters in height. And at last, we human beings or Homo sapiens to be 70 centimeters in height. Here, A is equal to 30 centimeters because evolution has started from ape with the length of the backbone of 30 centimeters. And D, or the common difference, is equal to 10 because each time the ape undergoes evolution, the length of the backbone increases by 10 centimeters. So let us consider a real-life situation problem. So there are 4 toll booths placed 5 km from each other. A car travels from A to D, find A and the common difference. So when a car travels from A to B, it travels a distance of 5 kilometers. And then when it travels from A to C, it travels a distance of 10 kilometers. And then when it at last travels from A to D, it travels a distance of 15 kilometers. Therefore, A is equal to 5 kilometers because arithmetic progression has started from when the car has covered a distance up to 5 kilometers. And D, or the common difference, is equal to 5 kilometers because the distance traveled by the car increased by 5 kilometers from every toll booth. Coming to growth. So when we grow, or when animals grow, and plants grow, we all follow arithmetic progression. So let us consider the height of 1 week old sapling to be 1 centimeter, and then a 2 week old sapling to be 2 centimeters in height, and then a 3 week old sapling to be 3 centimeters in height, and then a 1 month old sapling to be 4 centimeters in height, and at last a fully mature plant to be 5 centimeters in height. So here A is equal to 1 because arithmetic progression has started from a sapling with a height of 1 centimeter. And D, or the common difference, is equal to 1 because every week the plant increases its height by 1 centimeter. So let us consider women climbing these stairs. So each step has a rise of 5 centimeters above the ground level. Find the arithmetic progression in a given situation. So when the woman steps in the first step, she climbs up to a height of 5 centimeters above the ground level. And then the next step, 10 centimeters, the third step, 15 centimeters, and it goes on like that. So here, A is equal to 5 centimeters because the arithmetic progression started from a step with the height of 5 centimeters. And D, or the common difference, is equal to 5 centimeters because the height of each step increases by 5 centimeters. Let us find out the arithmetic progression in a situation where a ball bounces. So when a ball initially bounces, it bounces up to a height of 50 centimeters. In the second time it bounces up to a height of 47 centimeters. And the third time it bounces up to 40 centimeters. And it goes on like that, and last the ball comes to rest. So this is an example of decreasing AP because you could see that every time the ball bounces, the height up to which it bounces decreases by 3 centimeters. So here, A is equal to 50 centimeters because arithmetic progression has started from 50 centimeters. And D, or the common difference, is equal to minus 3 centimeters because the height up to which the ball bounces each time decreases uniformly by 3 centimeters. Then coming to arithmetic progression COVID-19 pandemic in our present situation. So this is a person. He gets infected by the SARS coronavirus and he becomes the infected person, and he infects 2 other people and they infect 4 others. This is how the coronavirus presents this present situation. With this, we can conclude that arithmetic progression is present everywhere in our day-to-day life. Thank you, everyone.
Today I'm going to check probability of different colored gems. So I have taken 2 cups. In cup 1 I'm going to add 3 colors of gems. In cup 2 I'm going to add 4 colors of gems. So now I'm going to take a random color of gem from this. So from cup 1 I've got blue. In cup 2 I have got orange. I've got blue and orange. So let's list out the sample space for this. So arranged a table. Let this side of the table be cup 1. And this side of the table will be cup 2. So I'm going to arrange the gems in the first cup. And now the second cup. Each box, each color. Now I'm going to write the combinations. So our sample space is ready. Now let's find the probability of the event. So the probability is 1 by 12. Favorable outcome by the total number of outcome. We got 1 by this table. We need BO and there is only one BO in this table. So 1 by 12. So if I had to ask the probability of getting a doublet, again, the total number of outcomes will remain the same. Let's go and check it in the table of getting a doublet. Doublet means in both the places we have to get the same alphabet in this case. So here 1 and 2, 3. So the here it will be 3 by 12. I can simplify it 1 by 4. So the probability is 1 by 4. So this is how we get our probability. Thank you.
Hello, I'm Reshma of class 7C. When I was in class 6, I simply used to memorize the diagonals of a regular polygon. But today, I've come here to exhibit on how to determine the diagonals of a regular polygon using a simple formula. The formula is D is equal to n into n minus 3 by 2. Over here, n is number of sides in a polygon and D is diagonal. So first, let's try the formula for a triangle. So the number of sides in a triangle is 3. So n is equal to 3. 3 minus 3 equals 0. So 3 into 0 equals 0. So 0 by 2 equals 0. So the number of diagonals is 0. Let's see how many diagonals are present in a square. Square has 4 sides and 4 vertices. 1, 2, 3, 4 and 1, 2, 3, 4. So the formula of finding the diagonal is 4 into 4 minus 3 by 2. So 4 minus 3 is equal to 1 and 4 into 1 equals 4. 4 by 2 equals 2. So there are 2 diagonals. and 5 vertices. 1, 2, 3, 4, 5 and 1, 2, 3, 4, 5. So the formula for finding the diagonal is 5 into 5 minus 3 by 2. So 5 minus 3 equals 2. 5 into 2 is 10. 10 by 2 equals 5. So the diagonal is 5. 1, 2, 3, 4 and 5. Here are some of the examples of regular polygons where I've applied the same formula in finding the diagonal. Hexagon has 6 sides and 6 vertices where the diagonal is 9. Heptagon has 7 sides and 7 vertices where the diagonal is 14. Octagon has 8 sides and 8 vertices where the diagonal is 20. Nonagon has 9 sides and 9 vertices where the diagonal is 27. Decagon has 10 sides and 10 vertices where the diagonal is 35. Dodecagon has 12 sides and 12 vertices where the diagonal is 54.
Hi friends, I am Harshita from Tulip. Today I am going to talk about maths in the world around us. Specific numbers we see in nature are called Fibonacci sequence. Fibonacci sequence tells us specific composed numbers that are sum of previous two numbers in sequence. It begins as 0, 1, 1, 2, 3, 5, 8, 13, 21, 34, 55 and continues indefinitely. Fibonacci series is a golden ratio in a sequence numeric form. This sequence was introduced by Leonardo of Pisa, who was also known as Fibonacci in 1202. How do we get this sequence? Here, each number is obtained by adding the last two numbers together. That is, 0 plus 1 is equal to 1, 1 plus 1 is equal to 2, 1 plus 2 is equal to 3, 2 plus 3 is equal to 5 and it goes on. Soon you will find yourself adding numbers in thousands and millions. Fibonacci number is divided by another Fibonacci number that came before it, especially the larger ones, you may get the same number, 1.618. So the ratio of 1:1.6 is also known as golden ratio of 5. When this ratio is expressed as a rectangle, it's called a perfect golden rectangle. If you split this golden rectangle into smaller squares based on the Fibonacci series and divide each with an arc, then it begins to take a shape of a golden spiral. Its importance is revealed in where we find it in nature. Starting from the fetus to the arrangement of Nautilus shell, we can see golden spiral everywhere. Golden ratio can be seen even in the helix of DNA. Take for example a sunflower whose seeds are arranged in a perfect spiral of 55, 34, 21, the sequence of Fibonacci. The fruitlets of pineapple create the same spiral-based sequence. The pine cones does the same. As the currents move through the oceans, the tides roll into the shore, waves curve into the spiral and follow a Fibonacci sequence. This blueprint can be seen in our body and around us on a small scale every day. The greatest can be seen directly above our head. On an average of 100,000 light years, even the spiral of galaxies above us are formed with exactly the same sequence. Do you know why the central incisors are bigger? It's because it is in perfect golden ratio to the laterals. The beauty of the face, the pupils of our eyes. In fact, the whole body is in perfect golden ratio. As you are listening to this video, the sound waves are entering your ears in a perfect golden spiral. Scientists have discovered that golden ratio pattern is necessary for the human brain, neural system, sense organs, lung system, etc. Musical instruments are actually designed with a golden ratio. When you look at the number of black keys and white keys on a piano, there should be no surprise if you see a golden ratio, and that's because musical notes are aligned with the Fibonacci series. Since golden proportion forms the base of the most beautiful patterns, it's also called a divine proportion. Thus, 5 becomes the most astonishing number, proving that math is the language of the universe. Thank you all.
Thank you for that amazing performance. Here come our seniors to draw the diameter of the dance circle. Thank you for unlocking our minds with the tap of your feet. Let's sink into the sea of integers with another exhibit.
My project is play with graph. Some feels graph is a boring part of maths, but we can create more interesting things with this graph. So before going to my project, we can see some basic functions. So I have built this graph with using 34 different equations. So let us see some different equations of conic sections. So let us see as parabola. Equation of parabola. General equation of a parabola is equal to y square is equal to 4xa. So I have drawn 4 different types of parabola. So by changing the A, you can see the different patterns, the beautiful things, which are created by graphs. And now let us see the ellipse. So even we can create circles. When A is equal to B, so the ellipse will be equal to the circle. So you can see that the ellipse is adjacent to the circle when the A and B is equal. Then let's go for a hyperbola. So the general equation of hyperbola is x squared by a square minus y squared by b square is equal to 1. And let us see some basic functions. So let us see modulus function. Modulus function is equal to simple. Y is equal to mod of x. And same a linear function. So y is equal to mx plus c. But m talks about the slope. So we can see here, as m changes, the slope changes. And the c talks about the intersection of the line with the y-axis. So it's a constant. So when c tends to minus 4, so this axis will change to minus 4, intersects at minus 4, same thing. And okay, so let us take a blank page. So I'm going to say 5 tricks where we can just convert your graph and we can make it beautiful. So let us take a modulus function. So that's equal to y is equal to mod of x. So we can see here that the function actually intersects x and y axis at the origin. If you want to change your graph, or you want just rise your graph by 5, just to add 5, so that your graph will be increased by 5 in y-axis. And same way, you want to decrease your graph by 5, just subtract 5, subtract minus 5. So you can see here the graph intersects y-axis at minus 5. Same way, you want to change the graph in left. It will change to the right side, and same way if you add it, it will change to the left side. So we can build the w from this modulus function. So let us take this modulus function, and we can decrease this by 5, and then we can make this whole modulus, because when it's whole modulus, so we will not get a negative function, so everything will be positive, so it looks like w. So you can actually limit this graph by using some inequalities. So let's have see here. So y is y is less than 20. You can see here w is limited till the 20. And so by using this, I have built for 3 different graphs. So this is my project. First thing is, I have written max by using 15 different equations, by using modulus functions and linear functions, and I will build a cartoon figure by using ellipse, modulus function, parabola and stuff. And finally, I have built a motion picture like a man is fishing. So this is a sine function. So you can see here the waves changes. This kind of motion picture. And even we can change the position of the sun by changing the value of z, the constant. So even we can do a lot of interesting things to graph. Even we can do differentiation, like tangent to the curve. So see here, this is a tangent to the curve, and same way we can actually learn this is a sine curve, which this is a tangent to the curve, and we can do a lot of more stuffs, interesting stuffs. So thank you. Try to build your graph.
My name is Avni Singh, and today we're going to do Equality Explorer question. So the first question is, x plus 1 is equal to 40. So we have to find the value of x. So first we have to put 1 to the opposite side. So from plus, the symbol will convert it into minus, because the opposite of plus is minus. So it will be 40 minus 1. If we minus it, we can find the value of x. The value of x is equal to 39. If we write it in the equation in the Desmos app, we can make a graph, and this indicates that these two numbers intersect at the point 39. So now let's go to the next question. So the next question is,
x plus 5 is equal to 11. So now we have to put 5 to the other side. So from plus it will be converted into minus. So it will be 11 minus 5. So if you minus it with 5, you can find the value of x. So the value of x is equal to 6. So now, if we write it, this indicates that these two numbers intersect at the point 6. This graph indicates that. Now the next question is x minus 3 is equal to negative 26. So we have to put 3 to the opposite side. So from minus it will be converted into plus. So it will be negative 26 plus 3. So if you plus it with 3, you can find the value of x. The value of x is equal to negative 23. So if we write it, we can find the graph of this equation. And now this indicates that these two numbers intersect at the point negative 23. And this is all the questions we discussed today. Thank you.
Hi, this is Carolyn of 8A. What is the square? It's a magic square. There's something special about this magic square. Each row, column and diagonal add up to be the same sum. See, each row, column and diagonal add up to be the same sum, which is 18. Now, before filling these boxes, you need to know 3 rules. Rule number 1 is the number is here, you need to move top right. The number is here, move top right like this. The number is here, I'm moving the number top right like this. The number is here, I'm moving the top number to the top right like this. Now, you might ask me, what if the number is over here? For that, you need to know rule number 2. You need to pretend there is a box here and then you need to jump to the end. You need to pretend there's a box over here and you need to jump. Now, rule number 3 is interesting. If there is a number over here and you are stuck up over here, you can't use the rule number 1. You can move the number down and proceed with the rule number 1. And now with the rule number 2, you can proceed. It's a bit confusing with lines and crosses. So I'll give you one example with numbers. Now I'm going to tell you in 3 cross 3. You can start wherever you want, but it's easy to start from the top middle. You can't use rule number 1 as there is no box over here. So we can jump on to the rule number 2. We can pretend there's a box over here and jump to the end. Again, rule number 2 applies. Pretend and jump. Now, as we are stuck up over here and there's a number over there, now we are going to use rule number 3 to come down. Now we can proceed with rule number 1. Rule number 1. Rule number 3. Rule number 2 applies. Again rule number 2. So we can check it by adding the numbers. See each. I hope you understood all the three rules which I explained. You can tie in different sizes, no matter big or small. Thank you. So we can check it by adding the numbers. See, I hope you understood all the three rules which I explained. You can tie in different sizes, no matter big or small. Thank you.
You're in the middle of a playground, observing the geometry of flowers, plants, and trees. Why are there trees in the middle of a playground? And also, why are you observing plants instead of playing? I don't know, maybe the playground is in the middle of the forest that you're stuck in. Moving on, you notice the presence of recurrent structures and forms in the alignment of the leaves, branching of the stem, the flower petals, and even the fruitlets of a pineapple. This pattern is given by a series of numbers called the Fibonacci sequence, and it goes something like this. It was first described in Indian mathematics around the year 200 BC. It was later introduced to Western European mathematics in the year 1202 by Leonardo of Pisa, also known as Fibonacci. And I don't know whether the sequence was named after him or if he was named after the sequence. In the Fibonacci series, every number is the sum of its previous two numbers. For example, 1 plus 1 equal to 2, 1 plus 2 equal to 3, 2 plus 3 equal to 5, and so on. Fibonacci series plays a central role in nature. How central, you ask? Very central. Like the trees in the center of a playground that is in the center of a forest kind of central role. No matter what kind of flower you are looking at, chances are it has 3, 5, 8, 13 or 21 petals, which are all Fibonacci numbers. The rows of seeds in sunflowers and pine cones always add up to a Fibonacci number. So do the number of fruitlets in pineapples. And this is not due to some cosmic mandate, but rather because it is the most efficient way to store as many seeds as possible. When you draw squares with successive Fibonacci numbers as dimensions next to one another, you get the golden rectangle. When you draw arcs from one corner of each square to the other, they join to form spirals similar to the ones in seashells, pine cones, and roses. Even hurricanes have such spirals. Fibonacci series is present even in the way leaves are aligned in trees. Starting from any leaf after 1, 2, 3 or 5 turns of the spiral, there is always a leaf aligned with the first. This is done so that all leaves receive sufficient sunlight. By the time you are done with the observation, you are rescued from the forest by passing by helicopter, unless the helicopter is not hit by a hurricane.
Hello everyone, this is Shailesh Vaidyanathan from 6B. I made a working model on angles. Now the angles come under geometry. Before going on to angles, I will tell a few points on geometry. What is geometry? Geometry, to say in few and simple words, is a branch of mathematics concerned with the properties of line, shape, size and angles. What is angles? Now as you can see that the entire working model is made out of thermocol and I have placed a protractor in the middle. And a protractor is an instrument used for measuring angles. Now what is an angle? Angle is formed from two rays sharing a common vertex. Now I tell you the types of angles. There are many types of angles. Now I tell about acute angles. acute angle is an angle which is lesser than 90 degrees. So anywhere from 1 degree to 89 degrees, anywhere you keep it is an acute angle. For example, 80 degrees is an acute angle, 60 degrees is an acute angle. Now I'll tell you about obtuse angle. Obtuse angle is an angle from 91 degrees to 179 degrees is an obtuse angle. For example, here see 110 degrees is an obtuse angle, 140 degrees is an obtuse angle. Now I'll tell you about right angle. Right angle is an angle which is 90 degrees. See here, 90 degrees you have to keep it perfectly. If you keep it at 91 degrees, it becomes an obtuse angle because 91 degrees to 179 degrees is obtuse angle. If you keep it at 89 degrees, it becomes acute angle because 1 to 89 degrees is obtuse angle. So you got it line it up perfectly. Now I'll tell you about straight angle. Straight angle is an angle in 180 degrees. You got to keep it perfect because if it becomes 179, it becomes an obtuse angle. But if it becomes 181, it becomes a reflex angle. Now I'll tell about zero angle. Zero angle is an angle which is 0 degrees. See in 0 degrees. Now I'll tell you about reflex angle. Reflex angle is an angle of 181 degrees to 359 degrees. Anywhere in that is a reflex angle. So this is the project I have made today. Thank you.
Here come the Celestial Legends with a dance performance.
Sin square theta plus cos square theta is equal to 1 beta. Then cos square theta minus sin square theta equals to cos 2 theta. 1 plus 1 equals to 11 नहीं होता बेटा. बाकी सब्जेक्ट्स में हम कुल बस मैथ्स में डब्बा मैथ्स में डब्बा मैथ्स में डब्बा मैथ्स में डब्बा मैथ्स में डब्बा. Oh dear Newton Einstein, how could you find it good? Maths में डब्बा maths में डब्बा maths में डब्बा maths में डब्बा.
यार मैथ्स किस किस का फेवरेट सब्जेक्ट है? मैथ्स में रूल्स नहीं है, सिर्फ जादू. तो तैयार हो मेरे बेस्ट फ्रेंड मैथ से दोस्ती करने के लिए?
दो मुर्गी तेरी दो मुर्गी मेरी चार तेरे मामे की. सात सुर में जो तीन ताल मिले धुन बने गाने की. दुनिया है सारी नंबरों से बनी बक्से से बाहर निहार. हम ना जरा भी कीड़े किताबी टेंशन मत ले यार. बोलो बेटा 1 2 3 4. तो डरना क्या मेरे यार. बोलो बेटा. तू टेंशन मत ले यार. तो डरना क्या मेरे यार.
Now we hand over the mic to Professor.
Yeah, thank you, Ashi and Komal. So I would like to thank our chief guest, Dr. Duraivel, and I would extend my heartfelt thanks to our principal to give the mathematics department such an opportunity to conduct the Max Week and to exhibit the young talents. I thank all the teachers from primary and mathematics teacher to involve in Math Week and the students to showcasing your talents in exhibit and the cultural activities, those who are involved, all the students. Thanks a lot, dear. So with this, we are winding up our Max Week. Special mention thanks to Srivatsan, who involved in editing all the compilation of the videos, and 12 students who did the quiz part, especially Pravesh, Sanjay, and then Suvisha, Suvisha, and then okay, the other students, and special thanks to Edison sir, who is a pillar of strength and giving rendering 2 songs, which is superb, and all the students are enjoying. Thanks a lot, sir. And Syed, your involvement is great, and thank you, sir. So thank you to all the parents who involved your students in this Max exhibit. Thank you.
To thee we give our heart, to thee we strive to play a worthy part. You give us strength to follow truth and right, and ever lead our feet towards the light. To thee we learn, the game exceeds the prize. To thee all fears and force forever fly, and in the hour when victory is won, teach us to be humble, faithful, study hard. When school is done, the study still our guide. We look to you when the clouds our pathways hide. Almighty God, be our vision and well. School of our youth, guide us still. To thee we learn, the game exceeds the prize. To thee all fears and foes forever fly. And in the hour when victory is won, teach us to be humble,